Okay, welcome back to our Module 2 on aerial photography. And I'm going to apologize now because there might be some background noise. My dogs have decided that they're really excited. So, so all this like recording at home stuff, right? So I have a squeaky toy in the background right at the moment. So it may or may not go away throughout this entire video. But so just carrying on, so objective 2.4, we are going to be talking about the geometric characteristics of aerial photography and photographs. So there's a few components to it, but that are not just geometric. When you get a photograph, especially if you get an analog photograph, you're going to have a whole ton of information all the way around it. So you have everything from the date, roll number, project number. You're going to see where the principal point is in the center in terms of something called fiducial marks. So I'm going to just stop there before I go too far. So the fiducial marks are these little like X's that you're going to see at the corners and sometimes in the center along the edges. In order to figure out the principal point, which is the actual center of the image, not necessarily the center of the ground, because those are two different things. If my airplane happens to twist a little bit, then suddenly the center of the ground in the image is in a different location than the principal point. But the fiducial marks say mathematically that is the center of the image. So that's what those mean. Then so we have the date, principal point, we've talked about those. We have the time that's always going to be there. Time's always important, right? Because especially if we're looking at real-time information, we need to know when it was taken. The focal length of the camera, and we'll get into what that means in the next slide. Then what negative it is. So it's kind of like naming your digital file, right? So it would be the digital file name when it was first captured on the camera. Then when you bring it into your computer, then you can change that name. So it's just kind of that name. Analog, it was always a number. It was the negative number. It also includes the lens information. So you need to know what lens you were using on that camera. And then your project information and the flying height of the actual airplane itself. So that's also really important. So you'll also see latitude and longitude. You'll see a predicted scale on there, what airport that is flying out of. You're going to see everything else up here that I have just listed there. So a lot of information is around this. We call that metadata, and we'll talk about that in the other class. But this provides me with the additional information about that camera or that particular image that I can use as a database to look it up, and I can extract all kinds of information, including scale information from it. So moving on to the geometry, there are a few terms I need you to know, and these ones are all listed here. So if we were to say that the camera is up here, the negative plane is where the film is, and then the positive plane doesn't actually exist in the physical world. It just exists in a ideological world, I guess, or an imaginary world. So the negative plane is the film. From the film to the focal point of the lens. So every lens has a focal point where all the rays come together, and at that point, that is the focal length. The focal length here to the positive plane is exactly the same. We use it just the positive plane to help with conceptualization of what's going on instead of having to inverse everything in your head, because now we're dealing with like triangles or similar triangles. So this big triangle on the bottom here is on the ground. So this is the ground all the way across here, and wherever that average ground elevation is, then we can calculate it up to the flying height, which is this h here. So we have these are the vertical pieces of information we need to know. The negative plane, the focal length or principal distance. I will always refer to it as a focal length. Then the focal length as well to the positive plane, the focal point, which is where the lights cross, and the flying height above the ground. So this is mean ground elevation, that would be above the ground. So we add a little bit more complexity to this and make it into 3 dimensions, because that's what we're actually acquiring. We have the optical axis, which follows through, which is which should, if you have a vertical image, it would match the principal point, because it would be the center of the image and then the center on the ground. And so it's going to be 90 degrees. And then you have your planes on each of these. So the distance now, as you can see, we have A, B, C, D around the edges there. And then we have A, B, C, D around the edges up here, and A, B, C, D along the edges of that photo. So remember that if you think back to physics, that you invert your image when you use a lens, right? So that's what's happening here. And so we go A to A. So it passes through A, and it passes, and you can see that it goes to the exact opposite corner. B happens to go there and goes to the exact opposite corner, and so forth. So it is crossing all the way across, making this focal point here. So it says exposure station. That's your focal point. That's really what's happening there. So we can see it flips on the negative, and the negative is what we're acquiring, and then we're going to convert it into the positive, onto the positive plane. So the next objective is the concept of photoscales. So there's a lot of calculations that can come with photoscales, and so this can be an actually like really big topic. So just when you see a scale on the actual aerial photo, it's just a predicted scale. It says, I am trying to get that scale, so try to fly your airplane as close as you can so we can get that. And it's assuming that we have a flat terrain. So if the terrain's flat, then it is going to be very close. But if we have a terrain that varies, then it's going to change as we go. So this is, if we were using a map and we were trying to calculate a map scale, the same process happens with the aerial photograph. So in definition, that ratio, it becomes a ratio. It's a 1 to something ratio. It says how large is 1 unit on the photograph to 1 unit on the ground. So it might be 1 to 5,000, which means 1 centimeter on the photograph is 5,000 centimeters on the ground, and it can vary from there. So the key thing here is there's going to be some variation across an entire raw photograph. So in order to make it exact, we will need to we're going to need to do math for every single part of that photograph, which can be very challenging unless you have an orthophoto. If you have an orthophoto, then that doesn't matter. So I'm going to just pause here, and I will come back to a new video just to keep it short, some of these shorter than what I have been. And then the next video, we will continue on with the calculations.